Hi, Kina. This is Tosh. Just giving you well, recording this for you. Um, I This is my second time recording it, so hopefully it works. But anyway, I took a look over your homework, and um, here's my thoughts. You're for the first problem. I looked at what you did, and it looks like you did everything perfect. I don't understand what the problem is. So, what my thoughts are, to be honest with you, is they're wrong. I mean, there's nothing else I can really say about that. It's like they are just, I don't know what they're talking about. They are straight up wrong because if you look at your graph, it's x minus 5 ln x. And it's, if you look at the graph, it kind of gives you this, oh, there we go. It kind of gives you this, like, bump down this way. Now, you have to understand that your minimum is technically at 5, but that's called a local minimum. It's minimized in that area because any value over here is going to be smaller than negative or than positive where 5 is. So that's your minimum in this area, but they gave you a specified region where they said between zero point 0.2, which I mean if you look at this one, it skyrockets up kind of pretty fast, and 7, which if you look at this one, it's not that big. In fact, it's still negative. So I agree with you that in this region, the region that they gave you, the local minimum is at x equals 5 and y equals negative 0.304 or something that you wrote down. And the local maximum is going to be at that endpoint right there. And that's how you do it. You evaluate all of them, and that's what you got. For your second one, your problem that you had was your algebra. You pretty much got the answer except the last part. It's kind of a small mistake, so I'll show it to you real quick. Um, I have it written over here. You start off with this d minus x cubed uh, equals 9x cubed. The way you're going to get rid of that cube root on the left side is you take the cube root of, or the cubed part of the left side is you take the cube root of it. Um, Now, when you take the cube root, or I'll just put 9x cubed to the 1/3 power. This 1/3 kind of meets both of these things over here. So this would be 9 to the 1/3 power. And this would be x to the 3/3 power, which is just 1. Those kill each other. So you still have x, and then it's not even that hard to solve for it anymore. You have d minus x equals the cube root of 9 times x. Bear in mind that the cube root of 9 is probably some kind of crazy decimal number that I'm too lazy to figure out. But what do? You take this x over to that side. That's why there's a 1 positive x. And then plus cube root of 9, and I just factor out the x. So I can get x all by itself. And voila, that's how you do it. Now for the last one I didn't solve out. I'm sorry. But here's what some of my thoughts are on it. Is if I were to graph them, you can see right here that for a time the cosine, which is the red one, right, is above the sine. And then from time for this region over here, the sine part is above the cosine. So what you're going to do is find what you want to find is where's that point that you break off? Where's that intersection point? The way you do that is you set those y's equal to each other. And you end up getting tan of x equals 4/3. Or x equals the tangent inverse of 4/3, which I ended up putting into my calculator, and I got 0.9272, um, or 53.13 degrees. But we're dealing in radians, I think, here. So what I would do is I would integrate from 0 to 0.9272, that intersection point, where I would have 4 cosine on top and 3 sine, not on top. I mean, it literally is on top when it's in the graph, but I would have 4 cosine minus 3 sine x. And then from my intersection point to my end point, which is zero point 0.6 of pi, which is zero point 0.6 times 3.14, blah, blah, blah. That's pretty much equal to 1.88. So I basically went to the end of their interval. They said start at 0 and end at zero point 0.6 pi. But I had to switch that up a little bit because what I need to do at this point is to take this 3 sine x, subtract 4 cosine x, because in this case, from that region to wherever it ends, the sine is on top and the cosine's on the bottom. So I'm going to subtract those two. And that's it.